Hello, everyone. I hope you're all doing well and staying healthy. Today we have another interesting talk in this seminar series. Today we host Rebecca Dizon-Ross from the University of Chicago Booth School of Business, who will be talking about incentivizing behavioral change, the role of time preferences. This morning you just have me for the intro. John's, I think, just caught up in some university matters right now, but he'll be joining a few minutes later. So really happy to have Rebecca. Rebecca's work is in sort of that vanguard of thinking about how do we understand the decisions that people are making for the investments in human capital, but also introducing sort of the role of optimizing treatment design for thinking about how to change people's behavior. So today's paper is just right on that area in terms of thinking about how should we design incentives that may vary with sort of the underlying preferences that people have, and today is going to be time preferences. So we also have Ariel Zucker, who's a co-author of Rebecca from UC Berkeley. Ariel will be sort of answering any questions that you might have on the Q&A, so feel free to keep with your questions on the Q&A. It's been great for the last couple of weeks, so thank you all for your interaction. Ariel will answer it, and I think that's it. So Rebecca, over to you. Thank you.
Great. Thanks so much, Rob, for the introduction. Thank you, and thanks for having me in this seminar series. Thank you all very much for coming virtually. So as Rob said, I'm going to be talking about a project called Incentivizing Behavioral Change, the Role of Time Preferences. This is joint work with Shilpa Agrawal at the Indian School of Business, who couldn't be here, and then Ariel Zucker, who you all just met a moment before. Oops, my clicker seems to be... See if I can get this. Okay. So incentives are a really core issue for economists. Figuring out how to design good incentive systems is important and relevant across a broad range of domains we care about, from the labor market, obviously, but also in education, health, so on and so forth. As a result of this importance, people have written down a whole lot of models to describe the contracting relationship. Vast majority of these models have paid relatively little attention to the role of agent time preferences, often implicitly assuming that agents are relatively patient, by which I simply mean that they don't discount the future very much. However, there's a lot of evidence suggesting that many people aren't like that. In particular, a lot of recent empirical work, particularly in the behavioral literature, suggests that many people are what I am going to call impatient, by which I simply mean that they heavily discount future events. So this raises an important question. If we are often incentivizing people who are impatient, is there anything we should be doing differently than if they were patient? Or said another way, what are the implications of agent impatience for the design of incentives? So in this paper, we try to shed light on this question in two parts. We begin by formulating predictions for incentive contract variations that we predict should improve the relative performance of incentives for people who are impatient relative to for those who are patient. So, and by improve performance, I just mean induce more effort from people who are impatient relative to for those who are patient. So that's sort of the theoretical part of the paper. We then have an empirical part of the paper where we'll test for the quantitative importance of implementing our variations and adjusting incentives for impatience. We're going to do this through an experiment that offers incentives for exercise to diabetics in India. Okay, so I'm going to tell you first a little bit about the contract variations and then move on to our empirical setting. When we formulate our incentive contract variations, one thing we recognize is this idea that people discount consumption differently than they discount future payment and effort. Okay, so just to draw this out, if I want to think about how people discount future consumption, I want to be thinking about their utility function. Okay, so here I've drawn out a standard utility function with exponential discounting. I'm not going to take a stand. There's a million ways I could write out the utility function. The key point I want to make is that the utility function is what's going to determine how I discount my own future consumption, how I discount my own future effort costs. In contrast, if I want to think about how people should discount future payments, well, payments are going to enter through the budget constraint. And so now I want to be thinking about what the budget constraint the person faces is, or what the lending environment they live in is. Okay, so here I've drawn out the budget constraint for perfect credit markets. Again, I won't take a stand. There's many different budget constraints people could face, but the key point is that it will be the budget constraint that's going to be a key determinant of how people discount future payments. Okay, so this point has been made many times before. The time preferences literature has established that there is this theoretical distinction between these two concepts, and not just that, that there's an empirical distinction between how people discount consumption and future effort and how they discount payments. So we are going to then build on this idea by sort of asking, so what are the implications? And in particular, what are the implications for the design of incentive contracts? Okay, and just to make sure we're all on the same page from a terminology standpoint, if I talk about someone who is impatient or has a high discount rate over their own effort, I'm talking about someone who wants to defer their effort costs to the future or who discounts future effort costs heavily. If I talk about someone who is impatient or has a high discount rate over payments, I'm talking about someone who wants payments sooner or who discounts future payments heavily. In either case, when I use the word impatience, I will include both people who might be time inconsistent or people who might be time consistent. I'm just thinking about how much do you discount those future events. Okay, so now moving on, based on this framework, we're going to develop two main contract predictions or variations. One which is designed to work well if people are impatient over effort and consumption, the other to work well if people are impatient over payments. So I'm going to begin by talking about the one that works if people are impatient over effort. Okay, and this contract variation, we're going to call it a time bundled contract. So let me explain what that is. I'm going to explain in the context of a simple 3-day model. Let's say I'm an employer and I'm paying someone to take actions on Monday, Tuesday, and Wednesday. So a benchmark way to pay them might be to pay them in a way that is separable over days or time periods. Okay, so that would mean that the payment they receive for their action in any given period or on any given day is going to be independent of the actions they take on other days. Okay, so I'd pay you as some function of the action you take on Monday, plus the action you take on Tuesday, plus the action you take on Wednesday. I'm not taking a stance about when these payments are delivered. They could all be delivered on Wednesday or all be delivered on Friday. The key point is that the payment function itself is separable in the actions in different days. Now I'm going to contrast that with what I'm going to call a time bundled function. So a time bundled function is a type of non-separable function, which means that the payment for action in any given day is actually going to depend on the actions I take on other days. Okay, so my payment function will be some non-separable function of the actions I take on multiple days. Let's make this concrete. Simple example, which is similar to what we'll use in our experimental setting. A separable contract might pay you $1 per day that you take some binary action. And a time bundled example might be that I would pay you $3 if you take binary actions on each day, but I would pay you nothing otherwise. Okay, so in order to get paid for your action on Monday, you know that you also have to take the action on Tuesday and Wednesday. So with that as background, let me now tell you what the prediction we develop is. The prediction we develop is that making the contract time bundled instead of separable can actually make the contract work relatively better for people who are more impatient over effort or who discount their own future effort costs. So later in the paper, I'll set up a very simple model to make the intuition clear. Let me just briefly preview what the intuition is now. Let's think about an agent on Monday who's deciding whether to take an action. If they're being paid in a separable fashion, then the mental calculus is simply compare the cost of the action on Monday to the payment they receive. They never think about their own future actions. Their discount rate over future actions never comes into play. Now, what's different about a time bundled contract? Well, on Monday of a time bundled contract, my mental calculus will be, do I want to take this action today, tomorrow, and the next day in exchange for payment? Okay, and so I'm going to compare the present discounted cost of that bundle of actions, i.e. the present discounted cost of doing it today, tomorrow, and the next day with the payment. So if I'm someone who discounts my own future effort costs, then signing up to do something where I'm taking actions in the future is going to seem kind of cheap, and so I'll be more likely to do it. Okay, so the more I discount my future effort costs, the more likely I am to comply with these time bundled contracts, and that's what drives our prediction here. Okay, and so we're saying that this prediction does seem to have, at least theoretically, has some bite. It's not that one of these contracts always dominates the other. The contract that dominates will depend on the specific setting, but you can set up models where if people were not impatient over effort, what you'd want to do is pay them separately. If they were impatient over effort, what you want to do is pay them in a time bundled fashion. So it does seem to have some empirical or some theoretical bite to understand how patient people are. And so just briefly, I mentioned this before, but so this prediction that making the contract time bundled makes it work relatively better if people are impatient over effort is going to hold for all different types of people who are impatient over their future effort. Okay, so this includes both people who are time inconsistent as well as anyone who's time consistent but just has a very high discount rate. And then among people who's time inconsistent, it's going to hold for two classes. It'll hold both for people who are sophisticated or aware of their own time inconsistency, and then also for people who are naive or unaware that they are time inconsistent. And so we consider the fact that these contracts are effective for people who are naive to be a really advantageous feature of these time bundled contracts. Why is that? That's because literature has suggested that there's a whole lot of people, so like maybe the majority of people, are somewhat present bias, but are at least partially unaware of the extent of their present bias. Okay, so naivete is very common. However, it has traditionally and so far been hard to address and hard to effectively motivate naive people. So that's one thing that we think is very promising about these time bundled contracts. Okay, so that's our first prediction. Our second prediction is much more, let me briefly tell you what our experimental design will be on these time bundled thresholds. So what we're gonna do in the experiment is we're gonna randomize whether contracts are separable, so that will be linear, or whether they are time bundled or these threshold contracts. Our primary goal will be to test whether relative to linear contracts, these threshold contracts work better for participants who are impatient over effort, i.e. to test prediction one that I just outlined for you before. But our second goal here is also just to examine the average effect of implementing thresholds. There's a huge theoretical literature talking about the effects of nonlinear incentive schemes, and our time bundled threshold is definitely a nonlinear incentive scheme. However, there's very little empirical work on this. So we're going to look at just empirically what happens when you move between these types of schemes. We won't have a prediction there for what the average effect of implementing a threshold is, but we do predict there might be some potential shifts in the distribution. In particular, thresholds might increase dispersion by causing some people to get over and some people to move down. Okay, so now I'm going to move on to our second contract variation. So as I said, now we're going to think about, well, what do we do if instead what people are really impatient over is payments? So this is a much more straightforward, much more intuitive prediction. It's probably the first thing that pops to your mind if you think about how you might want to adjust incentives for impatience. So the prediction here is just that if agents do discount financial payments, then increasing the frequency with which we pay people will improve performance, i.e. increase effort under the contract. So this is something that has been suggested many times. We are certainly not the first people to think of this. However, there is surprisingly little evidence on whether changing payment frequency actually makes a difference. Intuition, very straightforward. If you're someone who discounts future payments, then paying you sooner after action should be more motivating. If I pay you more frequently, then on average, I am paying you sooner. So our experimental design for this one will be quite simple. We will randomize whether payments are made monthly, weekly, or daily, and then look at the whether that affects effort. Okay, so the predictions I've outlined could hold in many different settings. They could hold for employers trying to motivate workers. So why are we using the specific setting of incentives for exercise to examine tailoring for agent, to examine how to tailor incentives for agent impatience? So I would argue that incentives for behavioral change, so things like exercise, losing weight, studying more, all things that were settings where we're kind of paying people to take actions that are ostensibly in their own best interest, this type of incentive structure is becoming more and more prevalent in the world. And while there are many different motivations that are used for such types of incentives, one of the motivations that you will often see is present bias or time inconsistency, which is in fact a type of impatience. It means I'm heavily discounting any future events. Okay, so present bias is actually an explicit rationale for the use of incentives in these settings. The reason is that because of present bias, people should discount the future costs of activities relative or future benefits relative to current costs. And so they will underinvest in these types of activities that have where the costs are borne in the present, but the benefits aren't realized until the future. Okay, so present bias could mean that we want to incentivize people in the short run for things that, for these types of behaviors. However, even here, where impatience is an explicit rationale for the use of incentives, there's been relatively little work thinking about, well, how should we make sure that we're designing these incentives in a way that actually works well for people who are impatient? So we thought this would be a nice setting in which to start, because it would be a setting in which we might think agent impatience might have a lot of empirical bite. Okay, so we'll conduct our randomized control trial in what we consider to be a very important policy setting. In particular, we're evaluating an incentive scheme to encourage exercise among roughly 3,000 people with diabetes and pre-diabetes in urban Tamil Nadu. So as you may know, in developing countries, just like developed, non-communicable diseases like diabetes and hypertension are exploding problems. Okay, there's estimates that the direct and indirect costs of diabetes in India are around 2% of GDP. So these are huge problems. And the best way to address these types of issues is to encourage lifestyle change like exercise. Okay, so that's why we chose to focus on this intervention, which has a lot of policy promise. So our primary goal with our RCT will be to shed light on the things I've just been talking about. How can we tailor incentive design to make sure that it works well when agents are impatient? So we're going to randomize the two contract features that I talked about before. First, whether the contracts are time bundled, and second, the frequency with which incentives are paid. We will then examine the main effects of implementing those contract variations, as well as heterogeneity in their impacts by measures of impatience, to try to assess how important is it quantitatively to adjust incentives for impatience. Our secondary goal here, though, will also be just a pure program evaluation. Does this incentive program work at improving exercise and health among people with diabetes? Okay, so let me just briefly preview the results before I get into the details. So overall, we think of our paper as presenting a new and nice way to adjust incentives to make them perform relatively better when agents are impatient over effort. In particular, the way we do that is we implement these time bundled threshold contracts, which we predict should work well if people are impatient over effort. And we find that empirically, they do in fact work better for the more impatient. So we find that they work 6 percentage points better at generating exercise for above median, people with above median impatience relative to below median. So 6 percentage points is a large impact relative to the sample average effect of the contracts, which is roughly 20%. Okay, we also find, as I said, we are also going to look at the average effect of adding these thresholds. There, we find that the contracts perform well on average as well. So they improve cost effectiveness by roughly 10 to 15%. However, they have a potential downside, which is that they increase dispersion, working better for some people than others, which really highlights the potential benefits of targeting these contracts based on things that predict efficacy. And in our particular case, highlight the importance of the fact that we now know that they are especially effective for people who are impatient. In terms of the other contract variation we implement, we find that increasing payment frequency, which we said should be good if people are impatient over payment, actually doesn't work well in our setting. And we find that it doesn't improve incentive performance, and we conclude based on this and other evidence that there's just limited impatience over payments in our setting. And then finally, from a program evaluation standpoint, we find that the incentive program itself has large and persistent impacts on exercise, and it also improves health. So overall, we conclude that this is a promising intervention for helping to decrease the burden of diabetes. Let me just briefly talk a bit about how we see this work fitting into the broader literatures. Okay, so I think the main literature that we contribute to is the literature on contract design with impatience and time inconsistency. So with some exceptions, this literature has by and large been focused on the use of commitment contracts, where agents demand a commitment contract or pre-commit themselves and restrict the actions of their future selves. However, so commitment contracts are a very useful tool. However, take-up of them is often low, and commitment can be ineffective or even harmful for people who are naive, who, as I said before, represent a large share of the population. So we see our work as really broadening the arsenal of ways to motivate people who are impatient and are time inconsistent. And instead, we take a different approach. We develop and validate these time bundled contracts as a new way to motivate a broad range of impatient agents. We also then perform a more direct test of higher frequency payments than has been done previously in the literature. We also tie into this literature on intertemporal choices over consumption versus money. This literature has focused on establishing the theoretical and empirical distinction between these discount rates, but hasn't done as much about thinking about why should we care? And so we're thinking about what are the implications for this for the design of incentives. And finally, we tie into a large literature on nonlinear incentive contracts. This literature is largely theoretical, so there's very few within sample comparisons of linear and nonlinear incentive schemes. So we show what happens and we provide new evidence that they can have sort of bimodal or discouragement effects for certain people. Okay, so the outline of the talk, I'll talk to you about the details of the experiment, then walk you through the effect of incentives on exercise, then talk through the contract variations that we implement to try to improve performance for those who are impatient, and then finally with time, I'll talk about the persistence of the impacts on exercise and impacts on health. Okay, so this is a randomized control trial evaluating incentive programs for exercise among people with diabetes and pre-diabetes. We're going to be working in Coimbatore, that's a city in Tamil Nadu in India. Okay, so India has very high rates of diabetes. It's sometimes known as the diabetes capital of the world, so a good place to try out these interventions. So we're going to have 3 main treatment arms, all implemented over a 12-week intervention period. The first arm will be the heart of our experiment, our incentives arm. So what does this look like? Participants are going to receive pedometers, and they'll also receive a daily step target. They'll be asked to try to walk at least 10,000 steps. And then if they reach their step target, they will receive some form of incentive, normally mobile phone recharges or credits played through a mobile account. These are worth 20 Indian rupees, so that's roughly 33 US cents, or in PPP terms, closer to $1.30 in US terms. Okay, so relatively small incentives. So if we see that incentives have an impact, it could be for 2 reasons. One is that people are being paid. The other is that we are monitoring their behavior through these pedometers. So to be able to disentangle those 2 effects, we also have a peer monitoring group. This group receives pedometers and a daily step target of 10,000 steps. However, they do not receive any incentive payments. And then finally, our third big treatment group is a peer control group, business as usual. They do not receive pedometers or a step target. Okay, so one thing to note is that we will only have pedometer data and good exercise data from the incentives and monitoring groups. So when we look at the exercise outcomes, we'll be focused primarily on those 2 groups. And then if we have time at the end to look at health impacts, we'll bring back in the control group for that. So within the incentives group is where the sort of heart of our experimental design is. Within this group, we are going to have sub-treatments where we vary the specific features of the contracts. Okay, so I'll go through this again when we look at the specific results, but we're going to have what this first contract on the left, we'll call this the base case contract. So this contract is going to be a separable contract that is played with weekly frequency. And then we'll have 2 contracts which pay with the same frequency, but change whether the contract is separable, and in particular make it time bundled. And then we'll have 2 contracts which, relative to the base case, leave separability the same, but change frequency. Okay, so basically everything's going to be compared to the base case and only varies 1 feature relative to the base case, allowing us to isolate what's the effect of changing time bundling, holding frequency fixed, or what's the effect of changing frequency, holding time bundling fixed. The outcomes we're going to look at, so for comparing incentive subtreatments, we're only powered for looking at behavior. So we'll look at exercise. In particular, we'll look at the percentage of days on which people reach their step target and the number of steps they take. When we look at health, we'll then look at an index of various measures, including blood sugar, BMI, and blood pressure. Our sample is that we're going to sample, we sampled people who were 30 to 65 years old, who were diabetic and or pre-diabetic, and who met some other inclusion criteria. And we sampled them through screening camps that we held across the city that we were working in. Okay, so these were in markets, temples, hospitals, so on and so forth. And we achieved a sample of roughly 3,200 people. And this sample is balanced on observables at baseline, which I won't show in the interest of time. Okay, so now let's get into some of the results of the experiment. I'm going to start by showing you the effect of incentives on exercise. So a couple points. First, I'm going to be comparing the incentive group with the monitoring group, not the control group, because we don't have exercise data from the control group. And so why do we think this is interesting? 2 reasons. One, it's of standalone policy interest. generating exercise is an important policy goal that can improve health outcomes. So that's one reason. And then the second reason is that we want to make sure that this is a good environment to play around with our contract variations. So if we weren't effective at generating exercise, it wouldn't be a very good laboratory in which to explore contract variations. Okay, so our headline result here is that our incentive program is very effective at generating walking. Okay, so I have two graphs here to show you that. Let's first take a look at the one on the left. So the height here is the fraction of days on which participants exceeded their step target of 10,000 steps. I'm showing this separately for the monitoring group on the left and for the incentives group on the right. The confidence interval represents the confidence interval for the gap between the bars. Okay, and that will be true throughout the presentation. That's why I only have one bar. So you can see whether things are statistically significantly different by checking whether the confidence interval overlaps with the other bar, which in general it will not. What do we see here? So on the left, we see that people in the monitoring group do exceed their step target on 30% of days, so they do sometimes meet it. However, we see a marked increase. The incentives group, just providing incentives, increases the percentage of days on which people exceed their step target by 20 percentage points, or roughly 67%. So that's a very large effect. It's larger than we expected, given the small size of the incentives we are paying. On the right graph, you can see how that maps to average steps walked. So people in the incentives group walk roughly 1,300 steps more on average per day than people in the monitoring group. So that's the equivalent of going on an extra 13-minute brisk walk on average every single day of the intervention period, or roughly a 20% increase in steps. This next graph just shows us how the incentives program impacted the distribution of walking. So these show histograms at the person times day level, where the x-axis shows the number of steps the person walked in that day in thousands. Okay, so for the monitoring group, we can see that there's a small spike at 10,000. So people were motivated to try to hit the 10,000 step target. However, we can see that the spike in the incentives group is much, much larger. So the incentives were obviously having some bite here. They obviously motivated people to try to get over that 10,000 step target. The other thing I note about this graph is that we were worried that by having this sort of threshold step target, that maybe we'd be incentivizing or motivating people who would have walked, say, 8,000 or 9,000 steps already in a day. But if you were only going to walk 2,000 or 3,000, you might not bother walking more. You might not be motivated. Instead, what we see in this graph is that there's less mass in the incentives group than the monitoring group everywhere below 10,000, and more mass everywhere above. Okay, so we really seem to be motivating people or on people days across the distribution of exercise, which is promising in that it was a broad-based improvement. Final thing I'll show on just the main effect on walking is that the treatment effects were very stable over time. So another concern we had was that maybe incentives would be really exciting for a couple weeks, and then people would sort of get over it and the treatment effect would go down. Instead, what we see is that here's a graph showing average compliance in the incentives and monitoring group by the week of the program. Okay, so the program was 12 weeks, so week 12 is the last week of the program. What we see that everybody's a little bit excited in week 1, but after week 1, the treatment effect itself is remarkably stable. So it suggests that the effect wasn't diminishing over this time, and that potentially policymakers could extend such a program if they were interested even longer. Okay, so having shown you that our incentive program was very effective at generating exercise, I'm now going to move on to the predictions and evidence to thinking about how can we tailor incentive design to make it work well for people who have impatient time preferences.
Okay, can I just interject with a question?
Yes, definitely.
There's been a few questions in thinking about whether people will falsely give the steps by trying to cheat. So it'd be good to give a sense of whether you think that's going on in the study, and whether or tips that we could have from researchers to try to reduce that cheating.
Yeah, definitely. So there's a couple different ways that we might think that people are probably thinking that people might cheat. One of them would be giving my pedometer to someone else. So I'm 60, maybe I give my pedometer to my grandson, and he goes runs around at school. So to try to assess that, what we did was we did randomized audits where we stopped in on people unannounced and checked whether they had their pedometer with them. And so we did 1,000 audits, and I think we found 1 or 2 instances of sharing. So it did happen, but in far less than 1% of days. So we're not too concerned about it going on. The other way you might think people would cheat would be that they'd somehow like, I don't know, put it in the dryer, or there's all these different things that you can try to do to kind of like get lots of steps. So the other thing that we do is that the pedometers track minute by minute data. And so we can see how many steps people took by minute, and we can see whether that ever leaves the range of what would be reasonable for people of this age. And what we find is that there's very few instances where people were moving their pedometers really quickly, and that it's completely balanced across the incentives and monitoring groups. So again, we find that reassuring to suggest that it wasn't a lot of times people, doing some sort of weird thing, or if they did find a way to cheat, they found a way to cheat that looks exactly the same pace as walking, which seems less likely. So those are the 2 main things that we do. And then finally, of course, the proof is in the pudding. If we didn't, if it was all cheating, we wouldn't see any impacts on health, but whereas we do see some health impacts as well. So that's the 3rd piece that we find reassuring.
Great, fantastic, thank you. Also a question about sort of the incidence of time preferences in the measurement. So Glenn Harrison asked a few questions about how the time preferences actually are listed with a sort of hypothetical, with a real, and how did that sort of link in with sort of the treatment design? Maybe you'll come on to this, but that would be helpful too.
I will come on to that in a few slides, so maybe I'll just defer that to when I'm talking about it. But yes, I'll get there definitely when we talk about those results. Okay, so as we talked about, we have 2 main variations we want to evaluate. The first is these time bundled contracts, which should work well if people are impatient over effort. So I'm going to start with that and then move on to frequency of payment. Okay, so just to remind you, the definition of a time bundled contract, it's a form of a contract that's non-separable across time, i.e. where my payment in any given period depends on behaviors I take in other periods. But what we call time bundled contracts doesn't constitute the whole space of non-separable contracts. Instead, it's a subspace where the defining feature is that these time bundled contracts have periods where the returns to future effort is increasing in current effort. So you can think of it as periods where I have sort of a dynamic complementarity in payment across periods. Okay, so the example that we'll use in the experiment, and that I will use in all the examples, are these dynamic threshold contracts, where you're only paid if you take action in a certain threshold number of periods. In general, the efficacy, the intuition for why these types of dynamic complementarity contracts work well for the impatient is that if the return to future effort is increasing in current effort, then a benefit of acting today is that your future action will have higher return. But so that benefit's only relevant if you want to take the future action. And so who wants to take future actions? Well, people who discount the cost of those future actions are more likely to want to take them. Okay, and we'll set up a model to make that more clear. But just to further make the point that it's not that all non-separable contracts would be time bundled. An example of a non-separable contract which is not time bundled might be where you're paid for doing something once. So you're paid for, if you over a week, you're only paid for a max of 1 activity. That would be a non-separable contract that is not time bundled and where our prediction does not hold. Okay, so we're going to be just talking about the time bundled contracts, these ones where the returns to future effort is increasing in current effort. Okay, and within this class, we're going to focus on some very simple contracts. The incentivized action is always going to be walking 10,000 steps in a day. Regardless of your contract, that's the incentivized action. The only difference is how we group those actions across time. In particular, we'll have separable or linear contracts in this case, where your payment will be 20 rupees times the number of days you met the step target. And then we'll have the time bundled contracts. These will all take the dynamic threshold form, where you have a certain minimum number of days on which you have to meet the step target. So we're going to use 2 in the experiment. We'll use a threshold level of 4 and a threshold level of 5. So for example, the 5-day threshold contract would look like this, where if you meet your step target on 0 through 4 days, you get paid nothing. If you meet it on 5 through 7, you get paid 20 rupees times the amount you get. Okay, so we do sort of pay on the margin here. You get paid more for 6 than 5 or more than 7 than 6. The only difference is from the linear is if you don't meet your threshold number of days. Okay, so both of these contracts are going to have pros and cons. Neither is going to dominate the other on average. And so many of these pros and cons have been cited before in the literature. So the types of things you might think about are that these separable contracts might provide more constant incentive pressure, so work well for people who might never be able to walk 5 days a week. They can also be better if there's uncertainty about one's future costs later in the week. The thresholds, on the other hand, can be more high-powered for people. They can, especially if I was already going to walk 4 days in the week without incentives, the threshold contracts can be particularly high-powered. Okay, so as I said, we have no prediction for which one will do better on average. That'll be just an empirical question. What we do have a prediction about is the heterogeneity in the performance of the threshold contract based on impatience. And our prediction there is that these time bundled contracts are going to have an extra advantage for people who discount their own future effort costs. In this case, it's discount the future cost of walking. Throughout the talk, let me be clear, when I say advantageous or work better, I am not talking about welfare. I'm always going to be talking about what I'll call the policymaker objective. The policymaker here wants to maximize the level of compliance relative to the payout. Okay, so we're going to be thinking about how do we get as much effort as possible relative to the payout. We won't be thinking about the welfare of the individual participants. So here's the very simple model to build intuition around our prediction. We have a 2-period model, time periods 1 or 2. In each period, the agent can choose whether to walk. So that's a binary thing. They can either set W to 1 and walk, or W to 0 and not walk. Walking will have some cost, ET, that will be certain and known in advance. And the agent will discount his effort costs on the next day with a discount factor delta E for effort. Incentives in all contracts will be delivered at the end of period 2. Okay, so we're going to be holding constant the frequency of payment and just varying whether the contract is time bundled. So the separable or linear contract will give the person some incentive, ML for linear, for every period they walk. The difference in the time bundled threshold is that you only get paid if you walk twice. So you get an incentive of M times 2 if you walk in both periods, but you get nothing if you only walk once. Simplicity will make utility linear in payments. These are small amounts. And then the discounting of future payments will depend upon the available borrowing, saving, and lending opportunities. Okay, so if it's perfect credit markets, I'll discount my future payments with the market interest rate R. To accommodate all different types of credit markets, we're going to denote our reduced form discount factor over payments as DM. So that'll be 1 over 1 plus R with perfect credit markets. Okay, so let's just build intuition on this one slide. Think through behavior in our 2 simple contracts. First, let's think about the linear or separable contract. In period 1, I'm going to walk, i.e. set W equal to 1, if my cost of effort, E1, is less than the discounted value of the payment that I would get on the next day. What discount factor do I apply? It's my discount factor over money. Okay, day 2, very similar. When do I walk? I'm going to walk if my effort cost is less than the payment I would receive on the same day. Key thing to note here is that my conditional on my discount rate over money, my discount factor over my own future effort never enters the equation. It doesn't matter. Now let's think about what's different with time bundled thresholds. Now, before I do that, let me note that in time bundled thresholds, the agent is going to have to think about their future behavior when they decide on their current behavior. As a result, we're going to have to distinguish whether people are sophisticated about their own time preferences or naive. So I'll start by laying things out if they're sophisticated and then move to the naive case. So the key difference in the time bundle threshold is that in period 1, I'm going to make a joint decision. Do I want to block both now and in the next period in exchange for payment? Okay, so what am I going to be evaluating in my head? I'm going to say I want to walk in period 1 if the present discounted cost of my effort in period 2 plus the cost of my effort today is less than the payment. Okay, and so the critical thing to note is that now my discount factor over future effort enters into the equation. The lower it is, or the more I discount my future effort, the more attractive it seems to walk today. If I'm sophisticated, I'm also going to consider whether I will follow through in period 2. So I'll only walk now if I'm going to follow through. And then in period 2, I'm going to walk if I walked in period 1 and if it's worth it from a monetary perspective. Okay, so the critical equation is this first one right here. It just shows us that the lower is your delta E, i.e. the more impatient you are, the more likely you are to walk under these threshold contracts. So that was the case of sophisticates. What happens with naives? Well, the only thing that happens is we get rid of this follow through constraint. The naive person assumes that they'll follow through in period 2 if they wanted to in period 1, but everything else looks the same, and critically the prediction still goes through. The more impatient I am, the more likely I am to walk. Okay, so the takeaway here is that these time bundled contracts have an extra benefit for agents with low delta E, i.e. who are impatient, because of what we call the cost bundling effect. We're basically bundling together the cost of effort today with the future effort cost. And so since they discount that future effort cost, they're more likely to walk today. Okay, so these low delta E agents discount their own future effort spent walking. And so we have a lower total cost for them when we bundle their effort, bundle current and future costs. Okay, so to summarize, the prediction is that relative to the separable contracts, the time bundled thresholds will work relatively better for agents who are impatient over effort. This holds for both time consistent as well as time inconsistent. And among the time inconsistent, it's going to hold for both sophisticates and naives. And so that efficacy for all these different types contrasts with commitment contracts, which are the other main thing that has been used to motivate impatient people. Okay, so our experimental design here, we're going to be focusing on 3 treatments. We'll look, our benchmark treatment will be the base case contract, which is paid at a weekly frequency and is separable or linear. Okay, and then we're going to control that with our 2 time bundled contracts. We have a 4-day threshold contract and a 5-day threshold. These are both weekly, so we're holding constant payment frequency and only varying whether the contract is time bundled. In the interest of time, we'll just we'll pool together the time bundled treatments together. So our primary goal here is then to test the prediction that the relative performance of time bundled thresholds is higher for people who are more impatient over effort. And then our secondary goal is to perform one of the first empirical comparisons of these types of contracts, and in particular of linear versus nonlinear contracts. We don't have a prediction there for the main effect, but we still think it's interesting given the prevalence of these contracts in the world. So we're going to begin with the secondary goal, move on to the primary. Okay, so the thresholds on average, we find they do not affect the average level of walking. So this shows that the percentage of days walked in the base case linear relative to the 2 threshold contracts is nearly identical. However, thresholds do increase cost effectiveness. So this right graph shows its conditions on days when individuals met their step target, and the y-axis is the percentages of those days on which they actually received payment for it. So in the base case or linear treatment, by construction, this must be 100%. We pay you for every day you went your step target, so that must be 100%. In contrast, in the threshold treatment, so let's say the 4-day threshold treatment, there might be some week where I met my step target only twice, and therefore I didn't get paid for either of those days. Okay, so we can see that people then, as a result, they were only paid for 90% of the days they met their step target in 4-day threshold and 85% in the 5-day. So it shows that there is this advantage of these contracts that they maintain the same level of exercise while improving cost effectiveness. One might say, is this just because people didn't know about the threshold contracts or didn't understand, didn't adjust? So that doesn't seem to be the case. We can look at the effects of the thresholds on dispersion, and we can see that the threshold effects do really affect the distribution of walking. So this is a histogram where each observation is a person times week, and the x-axis shows how many days in that week did they meet their step target. And so the base case is in orange, the linear. We compare that with a 4-day threshold. We can also compare it with a 5-day threshold, and the patterns become even more stark. You can see that adding the threshold really pushes people to the extremes. It's sort of like, if I was only going to meet my step target 3 days, it either pushes me downwards, discourages me, or it pushes me upwards to have higher. Okay, so we have more dispersed or bimodal effects in the threshold treatment, where we have more 0-day weeks and more 7-day weeks. I'll just go quickly in the interest of time here. This bimodality also holds at the person level as well. So this shows a kernel density plot of the average steps taken by an individual across the intervention period. And you can see that there's more mass in the tails in both threshold treatments. And we can easily show that the variance of steps is larger in those treatments. Okay, so this dispersion suggests that the thresholds work really well for some people, not so well for others. So these threshold contracts might be really good if we know which people to target. And that means it's nice that we have a prediction. We think we can target the people who are impatient over effort. Okay, so let's test whether there's heterogeneity in the impact of these threshold targets by impatience over effort. We're going to restrict our sample to the threshold and base case groups only. So the only difference between these groups is whether or not they have a threshold. And our dependent variable will be an indicator for whether the people met their 10,000 step target on a given day. Our prediction is that the threshold contract should be more effective for people with higher impatience, so beta 1 should be greater than 1. Worth noting, we certainly didn't randomize people's impatience. So this is a policy relevant estimate in that it tells us what would be the effect of assigning threshold treatments to different types of people. However, it's not a direct test of our theory, because our theory is about the effect of changing impatience, holding everything else constant. Okay, and so this will only directly tie to the theory if impatience is uncorrelated with other determinants of threshold performance. We do a few exercises. So we, for example, control for other potential determinants interacted with threshold, and we think that it is in fact pretty uncorrelated with most of the other determinants of threshold performance, but it is, we're relying on endogenous variation here. Okay, finally getting to the question about measuring impatience. So we did two things here. One was successful, one was not. So we have a sort of elderly and not very sophisticated samples. So our primary goal was to make sure we had measures that they could actually understand. And so we ended up using an index of simple measures of patience and self-control from the psychology literature. So this was measures like, I'm continually saying I'll do it tomorrow. I usually accomplish all the things I plan to do in a day. I'll skip over that point about who, for logistical reasons, these measures are only available for the second portion of the sample, but we have for the full sample a lot of very similar measures, and so we can predict with similar impacts. Okay, and so the psychology literature has validated that these measures do predict real behaviors, and in our sample, reassuringly, both the actual and predicted indices do correlate well with measured behaviors. So these measures seem to have worked pretty well. In contrast, we also tried measuring things with the incentive-compatible, incentivized context time budget method, which is pretty difficult to implement in a field setting, and basically people appeared to have not understood it at all. So we're not going to use that for analysis. Okay, so we focus on this measure 1. So our headline result here is that the thresholds do, in fact, have heterogeneity by impatience, and they work better for people who are more impatient. Okay, so the first row here that's highlighted in blue shows the interaction effect. So interpreting this first coefficient shows that people who are 1 standard deviation higher in impatience index, they have a 3.8 percentage points higher effect of being in the threshold treatment. To make things easier to interpret, we also run things with an above median impatience index. And so there we see that people with above median impatience are roughly 6 percentage points more likely to comply under the threshold relative to the non-threshold. Okay, so these are large effects relative to the sample average effect of the threshold, which is 20 percentage points. We get a 6 percentage point gap between those, based on impatience type. Okay, and then these next two columns just show that if we bring in the predicted measure, run things in the full sample, everything looks higher statistical power, but very similar coefficients. Okay, so just to see what this looks like graphically, I'm just now plotting these coefficients. So the left bar shows the effect of moving from a linear to a non-separable or to a time-bundled threshold for people who are below median impatience. So it shows that the threshold decreases walking among people who are not very impatient. On the other hand, among the people who are impatient, the threshold increases walking. Okay, so it means that we probably want to target these contracts if we can, based on the measures of impatience. And then the gap between these two bars is the 6 percentage point effect I was talking about on the previous slide. Very quickly, I'll just say that this heterogeneity is robust to controlling for other variables interacted with threshold. So we really don't think it's being driven by some omitted variable. We think it's likely impatience itself, but of course we can't say that for sure, since we don't have an exogenous source of variation in impatience. And then I won't go into the details, but we do also do a calibration exercise to try to, just benchmark and show that that in this context, with the costs that we observe, that impatience is really capable of moving threshold performance, and we see that it is. So all of these analyses come together to suggest that, consistent with our theory, the time-bundled contracts probably work meaningfully better for those who are more impatient over effort. Therefore, we conclude this can be an effective variation to improve relative incentive performance for people who are impatient over effort. And then from an average evaluation side, we find that on average, adding the threshold has pros and cons. The pro is that it decreases the amount paid per day, or is more cost effective by 10 to 15% while maintaining the exact same walking. The potential con is that it works while working well for some people, it doesn't work very well for others. And so it can be a very effective measure if you can target the contract based on impatience. Rob, let me check in with you on time. We're probably about 45. I have some other results I can show on frequency and thing, or I can just briefly summarize those and we can do questions. What do you prefer?
You can go through the rest of the slides that you have. I think we have like 3 or 4 minutes.
Okay, so let me just, so the other variation we do is to look at payment frequency. So there we have this sharp qualitative prediction that if people are impatient over payment, then paying them more immediately will have larger impacts. But of course, the quantitative importance of this is going to depend on how people discount payments. And so as we alluded in the beginning, if credit markets are perfect, then the discount rate will only be the interest rate. And so, you know, paying me at the end of the week versus today shouldn't have much impact. However, if we're in a setting with limited borrowing and savings, the discount rate over payments could be higher. And so this could have a higher impact. And so worth noting that in addition to the average level of discounting, the shape of discounting over payments matters as well. So if discounting has a kind of quasi-hyperbolic shape, where it's all about today versus the future, then you can only really get high performance if you pay people every single day. And you wouldn't get much gains from paying people at, say, the end of the week versus the end of the month. If instead the discounting sort of moves much more gradually, then you might get a smoother benefit of increasing frequency. And so this motivates us to try 3 different treatments. So basically we try a weekly treatment, a daily treatment, and a monthly treatment to really be able to trace out the shape and see what is the shape of discounting overpayment in these regions. Okay, so our primary goal is just to answer the policy question of does increasing payment frequency matter? And then we have a secondary goal, which is to use those treatment effects to say something about how impatient are people over payments. Okay, so our headline result here is that more frequent payments just don't seem to do much of anything. The differences are pretty small in magnitude. They're not monotonic, seem to be mainly noise. So higher payment frequency does not seem to significantly increase walking. So this suggests that people are likely just not discounting payments very much. To provide further evidence of that, we can also look within treatment and see how things moved as the payday approaches. So the prediction if people are impatient over payments is that as they approach their payday, if they're being paid, say, every week, as payday approaches, they should get more and more excited and compliance should go up. Instead, we see that compliance is totally flat, and we can rule out even small increases as the payday approaches. So people really just don't seem impatient over payments in this setting. Worth noting, that result contrasts with some other work, for example, by Supreet Kaur, Michael Kramer, and Sendhil Mallanathan. They don't randomize payment frequency, but they do look at payday spikes, and there they see them. So we think it's a great question for future work to try to look more at and in what situations people are impatient over payments, and so payment frequency might matter, and in which situations they are not. Okay, so in the interest of time, I'll just skip over the takeaways there. The final thing I'll show you briefly is the persistence and health impacts. Okay, so a big question with incentive programs is, does it only last while you pay people, or do people build healthy habits that last in the long term? So to assess this, we measured exercise in the 12 weeks after the program ended. So basically paid people for 12 weeks and then measured exercise for 12 weeks after that. And reassuringly, we still see significant treatment effects in that 12 weeks after the incentive program ended. Okay, so if you want to benchmark the size of these treatment effects relative to the treatment effects during the intervention period, the treatment effects are 40% as large, or 40 to 50% as large, depending on the outcome measure we use. So essentially, we're maintaining about 40 to 50% of the effect even after we stop paying people. So we think that's a very promising level of habit formation, and a great question for future work is to try to think about why we see such high persistence, whereas some other incentive programs have not seen quite as much. We then look at health impacts. So it's a little short run to look at health, but we just want to provide sort of proof of concept that improving exercise can move the needle on health here. So we benchmark incentives relative to the control group. So the first column shows the sample average effects. We expected larger effects among people who were more sick at baseline. So column 2 breaks things up between the people who had more severe diabetes and less severe diabetes. We do in fact see stronger effects there, but so basically we see about 0.07 standard deviation improvement in an index of health risk that includes things like BMI, blood pressure, blood sugar and things like that. So I think it's very promising that we're able to move the needle on health, even with this type of scalable intervention. Most interventions that move health for diabetics tend to be very not scalable and resource intensive. So ours is a much more scalable option that we think is quite promising from that dimension. Okay, I'll skip over that in the interest of time. So just to sum up, what do we do here? First, regarding contract design and impatience, we think we found a novel way to try to adjust incentives to make them perform relatively better when agents are impatient over effort. Okay, so we implement these time bundled threshold contracts, which we show are advantageous when agents are impatient over their own future effort. And then we show that empirically, consistent with our theoretical predictions, they do in fact work meaningfully better for more impatient participants. We also look at the average effect of those contracts. We show that on average, they do pretty well. They increase cost effectiveness. However, they also increase dispersion, highlighting the importance of being able to target on things like impatience. We then look at the effects of high frequency contracts. We show that that has limited efficacy, suggesting that people just don't seem to discount payments in our setting, and showing that one of the ways that people have theorized that you could adjust incentives for impatience doesn't seem to hold up, at least in our setting. And then from a program evaluation standpoint, we find that incentives are promising for decreasing the burden of diabetes. It's a pretty scalable program, has large impacts on walking. The effects persist after the intervention ends and translate to moderate short-run effects on health. So overall, we found this to be very promising policy for potentially moving the needle on the burden of diabetes. Okay, so thanks so much for having me. And if there's any questions that make sense to discuss, just let me know.
Awesome. Thank you very much, Rebecca. That was fantastic. And thank you for Ariel as well, answering all the questions on the Q&A. Really great. Well, one question that sort of popped up into my mind, and you mentioned it briefly when talking about sort of the impacts of the low versus the high patients in terms of the endogeneity. And it'd be good to get a sense of like, what are the observable characteristics that you measure that are different between the high impatience versus the low impatience individuals, and could they be driving some of the differences that you find?
Yeah, so I guess some of the things that we measured that we thought would also drive threshold performance and that don't seem to be doing it are, so we measured risk aversion, we measured sort of uncertainty over your future schedule, there's some wealth measures and things like that. None of those, controlling for any of those doesn't seem to matter, partly because none of those actually seem very correlated with our impatience measure. The thing that is correlated with our impatience measure is behaviors, which is like baseline exercise. That makes sense because we think that impatience will drive all kinds of behaviors. And so in some sense, it would kind of be okay if we controlled for those things and it made the effect go away. But surprisingly, even controlling for those types of behaviors in very flexible ways also doesn't seem to be driving the relationship. So it does seem to be something about, we conclude that it's likely something about impatience itself, but we didn't measure every single thing that it could potentially be. Oh, one more that people have raised several times that they've thought about is like sort of propensity to form habits, whether impatience might be related to that. So we didn't measure that because that's hard to measure, but we can look at our data on persistence and see whether impatience predicts that. Doesn't seem to. So again, that doesn't seem to be driving what's going on. So those are some of the main factors that we looked at. But any other suggestions, we're definitely welcome to, happy to try throwing some more things in and seeing whether anything else would kill it. Yeah.
Fantastic. And another question would be, if you could run this experiment again, maybe in a post-COVID world, what would you do differently, and where's kind of your research going in this area moving forward?
Yeah, well, so we are actually in progress or suspended at the moment on a follow-on project, which is thinking a lot about how do we target incentive contracts across people. Based on sort of inframarginal behavior. So basically, when we presented this project to our government partners, one of the things they noticed, they were like, oh, in the monitoring group, some people are walking a lot and some people are walking very little. And so how can we sort people more appropriate into, say, step targets so that we can get everybody to walk more? So basically, they said, like, can we get the people who are walking a lot into high step targets and the people who are walking not very much into lower step targets. And so we have a follow-on experiment right now where we're basically trying the classic price discrimination strategies to try to sort people in a scalable way. So we have one where we're trying to target those contracts based on observable predictors of walking, for example. So that's sort of the equivalent of like third-degree price discrimination. And then we have another where we allow people we provide them with a menu of choices where they would get paid more for higher step targets, less for lower step targets, and we see how they choose, what they choose, and then whether that's effective as well. So that's sort of like indirect price discrimination. So that's our next ongoing project, is thinking about targeting them not based on this threshold characteristic, but instead based on, since we feel like we learned a lot about that in the first project, but rather based on baseline levels of exercise and kind of level of inframarginal behavior.
Got it. Fantastic. Thank you, Rebecca.
Yeah, thanks.
I think we're just 1 minute over time. Thank you all for your participation. Thanks to Rebecca, obviously, for that great talk. Thanks to Ariel for going through all the questions as well. And next week, same time, we have Eric Bettinger from Stanford University giving his talk on does EdTech substitute for traditional learning? Experimental estimates of the educational production function. So thanks again, Rebecca. Great seeing you.
Thank you so much for having me. Yeah, thanks, Rob.
Thank you, and stay healthy and well, everyone. I'll see you next week. Take care, everyone.